Welcome to Engineering 10 Statistics. So we'll cover things like histograms today. So here's a histogram showing manufactured bolts for a car. We'll go through statistics, the basics of it, and a simple application for engineering. Statistics is about the collection, evaluation, and interpretation of data. So you can use statistics for your design. So it can help you verify the quality of a design or process. On the topics that we'll cover today, we'll talk about summary statistics, central tendency, variation, distribution. So summary statistics is about taking a big data set and understanding how you can pull a few numbers from it so you can understand the general trends of that data set. There's a central tendency, which is the center of a distribution. So for example, if we have some data set here, like a bell, so the variation tells you the spread of values around the center. The center we can kind of say is the mean, median, or mode of this thing. Variation is the spread. So examples of the variation would be range, standard deviation, or interquartile range. Then we got the distribution. The distribution helps you understand that variation. Distribution talks about the summary of the frequency of values. So that includes frequency tables, histograms, and normal distribution. We'll start with central tendency. So the mean, median, and mode set. So the mean is the average. It's the sum of values of the data set divided by the number of values in that data set. We have an equation here, but basically mu is the average or mean. Then sigma is the sum of all of the data points, where x sub I is all the data points, and n is the total number of, I can write it here, it's the total number of values in that data set. Before we get into the example, I have a little note. Don't round until the final answer. So if you're rounding intermediate results, you might get the wrong answer. Round only until the end. When you do round it, you have rounding to one more decimal place than the original data. So we have a data set here. These are basically a bunch of numbers. If you want to get the average, add up each of these numbers. So then you divide it by the number of values there are in this. So in this case, it's 11. So if you do that, which is 22.09 repeating, so that's 22.090909. We round to only one more decimal place than the original value. So like, let's say there's a 44. We don't have any decimal places here. So we're going to round this 22.09 repeating to one decimal point. Next is median. So that's basically the value that occurs in the middle, the very middle of that data set. So for example, the median of this data set is right in the middle. So there's 1, 2, 3, 4, 5, 6, 7. Item in the very middle is 6. We have 3 on this side and 3 on the other side. Don't have something right in the middle. So we have 1, 2, 3, 4, 5, 6, 7, 8 items on here. Right in the middle is here. So to get the actual median, you just take the average of the two numbers 4 and 5. Next is mode. So that's the most frequently occurring value in the set of data. Symbol is capital M. Again, a measure of central tendency. So the number that appears the most in this data set would be 21. 21 appears twice and the other numbers appear once. So M is 21. There are a couple of types of data sets for mode. Bimodal is when two numbers of equal frequency stand out, and multimodal is when more than two numbers of equal frequency stand out. In this example, first one, the mode is 63. 63 appears the most. Here we have a bimodal type. So we have 63 appearing twice and 59 appearing twice. So we have two numbers that are the mode, hence bimodal for 2. And the last data set, we have a multimodal type, 48 appearing twice, a 63 appearing twice, and a 59 appearing twice. Range is basically the difference between the smallest to largest value. R would be the maximum value minus the minimum value. In this case, the smallest number is 3, biggest number is 44. So 44 minus 3 is 41. Standard deviation, there's an equation for this. It's the measure of the spread of data values. A larger standard deviation indicates a wider spread in data values. So the equation square root of the sum of your data point minus the mean, so the average, so I'll say point minus average squared, and you take all of that and divide it by n, the number of terms that you have. So it helps to do this in a table. such as Excel, and you can also do it by hand, which I'll show you how it's done here. But the way to do this is you take the point and the average, subtract it for every data point that you have, square it, add up all of those points, and then divide by the number of points that you have, and then square root that whole thing. So the procedure here, calculate the mean, mu, then subtract the mean from each value, and then square the difference. Step 3 is sum all the squared differences. So now we sum them all up. Step 4 is divide by n. And then step 5 is square root the whole thing. So a reminder for rounding, don't round until the final answer. Standard deviation, round to one more decimal place than the original data. If you had 23.9 as your original data point, your final answer should have 2 decimal points. So 41.01, for example. Let's do an example of standard deviation. So if we have this set of numbers, we first have to get the mean. So the mean would be adding them all up and dividing by 11. We get 47.63 repeating. Then you take that 47.63 and put it into the equation right here. So you basically have that data point minus your mean. So data point, let's start with 2 as our first data point. So 2 minus the mean squared equals this 2000 number. So we did it for the first data point. Now we do it for the second data point, 5. So 5 minus the mean squared is this 1800 number, about the 2000, 1800. You repeat, you do this for all the points, and you eventually get all these numbers, which you need to add up. Adding them all up, so that sum part will give you 5,000 in the end. Now that sum divided by n, it gives you 456. And then the last step is to square root the whole thing per the formula. So we get 21.4 as our result. Lastly, we'll talk about histograms and some other ways to visualize these data points. It's very important to visualize because we can use this information to better understand the process. For example, this is a manufactured bolts for a car. You are an engineer trying to manufacture a bolt, but due to the manufacturing process, such as different instruments, temperature fluctuation, impurities in the material, different operators operating the machinery, you basically have variations in your manufactured piece. It looks like our central tendency is 0.750, and this is in inches. So we were aiming for this 3/4 of an inch bolt, basically. But we have this variation where we have some that are less than that size and some that are bigger. And those were due to those external factors. So the bolt lengths vary. There's a variation that causes this spread around the central value. And as the engineer, you decide what is acceptable. So you could say, I would allow this 0.749 and this 0.751 bolt lengths as well. And that means I'd have to scrap the rest of it. So improving the manufacturing process and understanding histograms is a big part of this whole thing, because you have waste here and you can improve the process, maybe reduce that spread. A histogram is a common data distribution chart that is used to show the frequency with which specific values or values within ranges occur in a data set. Look at the variation that exists among a group of parts that are intended to be identical. So how does this look and how do we make one? Well, we have a large set of data. We divide them into groups. So in the histogram, these groups are called class intervals. They're also called bins. So it's basically like an x-axis where we start off. We eventually want to make something that looked like that histogram example. So a couple of bins, and then here would be like the frequency and the spread of this thing. First, we need to start with the x-axis. So this x-axis is the class interval. So in this case, we have an interval of -16 to 6 in this first bin, -5 to 5 in the second bin, 6 to 16 in this last bin. You choose the interval, basically. So this is just an example of an interval that's chosen. These specific bins are chosen, and your data points fall within these. So we have the x-axis. Now we need to look at the y-axis, which is called the frequency. So it's basically the amount of items or points that fall into each bin. So in this case, from our data set, we had 5 items here that were from -6 to 6 -16 to 6 goes up to 5 in the y-axis. And you can see the other frequencies of these other portions here. So I'll show the example where a data set given to us and you have to construct the histogram. So this could be done in Excel or Google Sheets or by hand. So this is how it's done by hand. We have this data set. The numbers are completely out of order. So we go 1, 7, 15, 4. You order them this, so you have a better idea of what the points are. And now we're going to put them into bins or the class intervals. So in this case, we kind of grouped them up already. So we'll put the 1 to 5 items in a bin, the 7 to 10s in this second bin, and then the bigger numbers 12, 15, etc. in the third bin. So our intervals will be 1 to 5, 6 to 10, and 11 to 15. That's because you can split up this data set evenly into 3. So you basically look at the number of points in this data set, split it up, in this case, split it up into thirds, and that's how each class interval is made, 1 to 5, 6 to 10, and 11 to 15. Right at the point between the intervals, it's kind of like the split of 5 and 6, which is 5.5. It's a split of the two ends here. So like this tick right here would be 10.5. It's between 10 and 11. But basically, we need to make bins. So once you make the bins from your data set, you can start filling up the frequencies. We have the 1 to 5, 6 to 10, 11 to 15. And the frequency just tells us how many items are in that bin. So 1, 4, and 5, there's 3 data points that are in this portion. We plot it to a frequency of 3. In the 6 to 10, we have 1, 2, 3, 4. So 4 items. And in the last portion, the third interval, 11 to 15, there are 2 items. So we plot that with a frequency of 2. Dot plot is similar, where it's kind of like a histogram, but we represent the data as a dot. You can just use dots to represent the frequency in this case. So let's look at an example. Here, we have like these data points, and you make an x-axis where we have intervals, just like before. In this case, our intervals are pretty much like 1 item each. -1, 0, 1, 2, 3. These are basically like each data point in this table. So it's not like a 1 to 5 kind of thing previously. It's now just like that one number. So for example, 0, we'll start off from the very top of this table, the data set. There's a 0 here, so I can plot a point, meaning there's a 0 data point in this dot plot. Then we'll go to 3, so you can follow the line here. We have a 3 in this dot plot, a -1 here, -3. If it repeats, so we're at 3 again, for example, we just stack it on top. It's kind of like a histogram in that sense, because if you fill these in as if they're bars instead of dots, we have a histogram. These bars tell you the frequency. So for example, frequency 1, this bar height, frequency 2, frequency of 4 here, because there are 4 dots. So it's similar to that previous example of a histogram. So again, these notes are available for you to review. You can see the histogram example. Lastly, we have normal distribution. So normal distribution is visualization where it's symmetrical when you have the shape plotted out. We can also look at how the data values are distributed among all the possible values of the variable. Specifically, we will talk about a normal distribution or bell curve. So the bell curve has a peak at the very center of the data set. It looks like this. So at the very center of this data set, we have the peak. And if you reflect this, it means it's symmetrical along this line that's at the center. And that's it. So the frequency in here, in this drawing, it's like a dot plot. We have a bell-shaped curve as the shape. So this normal distribution, you can see this in grades, for example, in classrooms where few people would get A's, the majority would get like B's and C's, and then the minority would also get F's.